Hello. Today I want to show you how I make building placement in grid. In this feature, I can place building in grid. I can rotate building. I can cancel building placement action. I can delete building. Let me review the files that I already have. I had an enumeration called GameState that has idle, placing building, and selecting building, and a cell-state enumeration that has idle, can place, cannot place, and selected. In the building type enumeration, I had vertical, horizontal, square 2x2, and L-shape. This is my building material. It has a color parameter and an opacity parameter. This is my cell material. And I had all 4 meshes. Now, let's create an object for the shape helper. Create a function named getHorizontal. Then, create 2 endpoint nodes. Make them as an array, then set the output array. Duplicate the function. Then just change x to 0 and y to 1. Create a function named square 2x2. Make 4 endpoint nodes. First endpoint node set x equal to 0, y equal to 0. Second endpoint node set x equal to 1, y equal to 0. Third endpoint node set x equal to 0, y equal to 1. Fourth endpoint node set x equal 1, y equal 1. Add them into make array node. Then set as output. Create a function named getLShape. Then create another 4 endpoint nodes. X equal to 0, y equal to 0, x equal to 0, y equal to 1, x equal to 0, y equal to 2, x equal to 1, y equal to 0. Create a function named getShapeFootprint. Create a switch on building type. Then set the return output to the same name as the functions we have created. Now, let's create a cell actor. Create a Boolean variable named isOccupied. Create an endpoint type variable named gridChord. Create a cell state enumeration variable type named current state. Create a function named setCellState. Set the current state with the input function, then create switch state from it. Add a static mesh, then set to plain mesh. Set material to white cell material. When in the idle state, set material to the cell's white material. In a can place state, set material to green. In a cannot place state, set material to red. And in the selected state, also set the material to red. Create another function named setOccupied. Then we can update the isOccupied variable with the input from the function. Create an actor and name it building. Create a Boolean variable named isSelected. Create a variable named building type. Then set its type to the building type enumeration. Create a variable of type integer and name it current rotation. Add another variable named shapeHelper. Add another variable named current footprint. Set its type to endpoint array. Create a variable named grid chord. Type as endpoint. Set the current rotation to 0. Add a static mesh component. Create a function setSelected. Create a branch to check if it is true. If true, set material to the building's selected material. If false, set material to the building's solid material. Create a function named getFootprint. Use the building type variable to switch states. Create a local variable named baseFootprint. Set its variable type as endpoint array. Change the variable type of shapeHelper to the shapeHelper object. In the switch building type state, set baseFootprint with the same name as our switch state. Merge all 4 state pins to continue the function flow. Create a local variable named rotateFootprint. Set rotateFootprint with baseFootprint. Create a for loop node. Then use the current rotation variable divided by 90, then set it into the last index. Let's go back to the shapeHelper and create one more function called getRotate. Create an input function variable of type endpoint array. Then, use it to create a for each loop. Create a break endpoint from the array element. Then use y multiplied by -1. Then create a make endpoint node. Then set the y value to x and the x value to y. Create a local variable of type int point array, named it as out. Then add an array element with the make int point node. When the loop is complete, use the out variable as the output in the return node. Now let's go back to the building actor blueprint. Use the shape helper to call the getRotate node. So right here I forget to set getRotate function as pure function. Set rotate footprint into input getRotate node. Then set it to rotate footprint. When the loop is complete, use rotate footprint as the output. Create a new function named setSolidBuildingMaterial. Drag static mesh, then call setMaterial function. Set material to solid building material. This function is called when we put our building in the grid. Let's create 4 children of it. Name them vertical building, horizontal building, square 2x2 building, and L building. In the building blueprint, I forgot to construct the shape helper object. In begin play event, create construct object node, then set class to shape helper class. Then set a shape helper variable. Create a build manager actor that is responsible for all the logic. Create a variable named gridCell, variable type as cell array. Then duplicate it and name it previously highlight cell. Create variables width and height, type as integer. And a cell size variable, type as float. Set cell size to 100, width and height to 10. Create a variable current game state, variable type as game state enumeration. Add another variable named select building, variable type as a building object. Duplicate it and name it held building. Let's create a helper function named getGridStartLocation. Use the width variable multiplied by cell size, then divided by 2 as the x value. Just change the width variable to the height variable multiplied by cell size, then divided by 2, and use it for the y value. Create a getActorLocation node, then subtract it with a makeVectorOutput node. Then we can set it as the output value. Create the world-to-grid function with a world position vector input. Subtract world position with getGridStartPosition function. And then use a break vector node on the result. Use x divided by cell size, and the same for the y value. Then make an endpoint for the x and y values. Now we can use the makeIntPointOutput pin as the function's output. Create a function named grid2world. Add an input variable function type, inPoint named it as grid. Use x multiplied by cell size, then add with cell size divided by 2. Do the same with the y value. Create a makeVector node. Set the x and y values to it. Then use the getGridStartLocation node. Add it with the makeVectorOutput pin. Now we can use it as the output function. Set all the function as pure function. Create a function named isValidCoordinate. Add an input variable type inPoint and renamed it as gridCoord. Then use x to check if it is greater than or equal to 0, and do the same with the y value. Then check if x is smaller than width and y is smaller than height. Then use in and Boolean node to check and return as the output function. Create a function named getCell@gridCoordinate. Add an input variable function of type inPoint, name it as gridCoord. Use the gridCoord wire to the isValidCoordinate node, then check the branch. Break the gridCoord pin into x and y. Then use y multiplied by width, then add with x. Promote it to a local variable named index. Use the index to check if it is greater than or equal to 0. and use the index to check if it is smaller than or equal to the grid cell array length. Use the grid cell array and get a copy from the index node, then return it as the output. Create a function named getCell at world position. Add an input variable function of type vector3 and name it world position. Use the world position pin plugged into the world to grid node. Then plug that into the getCell at grid coordinate node. Then return as the output. Create a function initialize grid. Create two for loop nodes. The first loop uses the height variable subtracted by 1, then set into the last index loop. Then promote the index to a local variable named y. The second loop uses the width variable subtracted by 1, then set into the last index. Then promote the index to a local variable named x. Make an endpoint from x and y. Then plug it into grid to world and set the output to the spawn location pin input. After the cell spawns, we set the grid coord with x and y, then add it to the grid cell array variable. Create a function named clearHighlight. Use the previously highlight cell array in a for each loop, then call the setCellState function and set the current state to idle state. After the loop is complete, clear the previously highlight cell array. Create a function named validate and highlight placement. Create two input variables, endpoint and endpoint array. I promote these to local variables just to keep the blueprint clean. Use the current game state to switch on the game state. In the placing building state, call the clearHighlight function. Then create a local Boolean variable named canPlace, then set it to true. Use the footprint node to create a for each loop node. Then use the origin node, add it with the array element, and promote it to a local variable named coord. Plug the output coord node into the isValidCoordinate node, then check if it is not true. If it's not true, set canPlace to false. Use the getCell at grid coordinate node with input of coord local variable node to check if the cell is valid. Create a local variable named cell to highlight as a cell variable array type. If it valid, add cell to highlight array with output of getCell at grid coordinate node. Then check if cell is occupied. If it true, set canPlace to false. After the loop is complete, we use CanPlace to check a branch. Create another local variable named highlight type, variable type as cell state. If it is true, we set the highlight state to CanPlace. If it is false, set the state to cannot place. Then merge these two pins to continue the flow. Use the cell to highlight array variable node to create a for each node. Call the function setCellState from the array element. Then set the highlight variable into function input. Use the previously highlight cell array to add the array element. After the loop is complete, we set CanPlace to true. Create a function named commitBuilding to grid. Use the held building variable to check if it is valid. Use getCell at world position node with input of held building getActor location. Then promote it to a local variable named currentCell. Use the getFootprint node from the held building to do a for each loop. Use the currentCell's gridChord node, add it with the array element, and promote it to a local variable named chord. Use the isValidCoordinate node to check the branch. If it is true, use getCell at gridCoordinate node with the input chord variable. Then call the function setOccupied and set is occupied to true. When the loop is complete, we call the function clearHighlight. Use held building variable node to call setSolidBuildingMaterial function. Then set it to empty and set the current game state to idle state. Create a function named rotateHeldBuilding. Use the held building variable to check if it is valid. Get the current rotation variable from the held building node, add 90, then modulo 360. And set it to the current rotation variable from the held building variable. Use the held building node variable to create a setActor rotation node. Get the actor rotation from the held building, then split into struct. Use X plugged into the X rotation, Y into the Y rotation, and Z add with 90, then set it to the Z rotation. Drag validate and highlight placement node into. Use getActor location node from the held building, then plug it into getCell at world position. Use it to get the gridChord variable, then set it to grid origin. Use the held building node to get the footprint array variable, then set it into the footprint input. Create a function cancelCurrentAction. Use the current game state for a switch. In the placing building state, check if the held building variable is valid. Then destroy the held building. Set held building to empty, Then call the function clearHighlight. In the selecting building state, use the select building variable to check if it is valid. If it is valid, we call the function set selected from the select building and set it to false. Then set the select building variable to empty. Merge the end two pins together and set the current game state to idle state. Create a function name, select building on grid. Add an input variable named target building, variable type as a building object. Do a check to see if it is valid. If valid, set select building variable with the target building input. Then call the function set selected and set it to true. Set the current game state to selecting building state. Call the function cancel current action after we check if the target building is valid. Create a function named deselect building. Use the select building variable to check if it is valid. If it is valid, we call the function set selected and set it to false. And set the select building variable to empty. Then set the current game state to idle. Create a function delete select building. Use the select building variable to create a get actor location node. Then use the output plugged into the get cell at world position node. Promote it to a local variable named cell. Use the get footprint from the select building variable node to create a for each loop. Create a grid chord from the cell local variable, then add it with the array element. Then plug it into get cell at grid coordinate node and call the function set occupied and set is occupied to false. After the loop is complete, we destroy the select building actor and set select building variable to empty and set the current game state to idle state. Create a function named update cursor building position. Check if held building variable is valid. If valid, use current game state variable for switch state. In place building state, we're using a line trace for finding a position in the world. Create a get player controller node and find get mouse position node. Use the get player controller node again, then call the project screen to world. Set screen X to the mouse location X and screen Y to the mouse location Y. Use the output world position for the start of the line trace. And use the output direction multiplied by 50,000. Add it with the output world position. Then set it into the end of the line trace. Plug the output hit location into the get cell at world position node. Then check if it is valid or not. If valid, we promote it to a local variable named hit cell. Set the held building position with the grid to world node that has input from the hit cell's grid chord node. Drag the function validate and highlight placement. Then set the hit cell's grid chord variable into grid origin input, and the held building footprint variable into the footprint input. Create a function named spawn and attach building. Create two input variables, type building class reference and building type enumeration. Again, I promote these to local variables just to keep the blueprint clean. We call the function cancel current action, then spawn the actor building from the input function. After we spawn it, set the held building variable with the output from spawn. Set the building type with the local type variable. Set the current rotation from the held building variable to 0. Set the current game state to placing building state. Call update cursor building position. Create a function named handle left click. Use the current game state for a switch state. Copy the line trace node that we already had. Paste it into the idle state. Cast to building class from the output hit actor. If it is valid, set the building output into the target building variable input and select building on grid node. In the placing building state, we use the held building variable to check if it is valid. Use held building variable to get actor position node, then plug into get cell at world position cell. Then check if cell is valid. If it's valid, call function validate and highlight placement. Drag output from get cell at world position node and get grid chord variable, then plug into grid origin input. Get footprint array variable from held building variable, then plug into footprint input. Invalidate and highlight placement function. It should return output check can be place or not. Fix it by place can place variable in return node. Now we do a check. If we can place, we call the commit building to grid function. Create a function handle right click. This function is responsible for the cancel current action. Create a function name handle rotate key. In the placing building state, we call the rotate held building function. Create a function named handle delete. In the selecting building state, we can call the delete select building function. In the begin play event, we call the initialize grid function. In the event tick, use the held building to check if it is valid. If it is valid and in the placing building state, we call update cursor building position. Now we are done with Building Manager Actor. I don't have a camera in the level yet, so let's create it. Add a camera component. Then create a Get Player Controller node. Then call Set View Target with Blend node. Set the new View Target to Self. Now, place the camera into the level, then set it to any position you want. Create a game mode blueprint. Set it in the world settings. And create a player controller blueprint. In the Begin Play event, we spawn our building manager, then promote it into a variable. Create keyboard event 1. Then use build manager variable call function spawn and attach building. Keyboard event 1. I set spawn class to horizontal building class and set building type to horizontal. For keyboard event 2, I set spawn class to vertical building class and set building type to vertical. For keyboard event 3, I set spawn class to 2x2 building class and set building type to square 2x2. For keyboard event 4, I set spawn class to L building class and set building type to L shape. Use our keyboard event for hand rotate key function. Use left mouse keyboard event for call handle rotate key function. Use D keyboard event for call handle delete function. And right mouse for call handle right click function. Set our player controller into game mode player controller. In the event begin play building actor blueprint, use static mesh to call function set material, then set to ghost material. Now let's spawn our building. Check the bound is correct. Left mouse, placing building in the grid is working. Rotate building is also working. Delete building is also working. I think it is done here. If this video helped you, please like and subscribe.